This experiment will show us how solids expand. We will fasten a soda straw between two blocks of cork and bend it. We have mounted a piece of aluminum foil to a rubber band. We place this over the stem and attach the rubber band. The other end of the aluminum foil is attached to the cork, and we adjust the tension so the straw is positioned vertically. If we place a lighted match under the foil, you can see the results of the thermal expansion of the foil very rapidly. The heat moves the straw to the right. It goes back to the center position when the foil cools and contracts. The heat moves the straw to the right. The heat moves the straw to the right. It goes back to the center position when the foil cools and contracts. The heat moves the straw to the right. It goes back to the center position when the foil cools and contracts. Thermal expansion of liquids can also be demonstrated. Thermal expansion of liquids can also be demonstrated. This experiment will allow us to measure thermal expansion of 3 liquids. 3 vessels are filled with different liquids and suspended in a water bath. The water temperature is 25 degrees Celsius. The 3 liquids are water, oil, and carbon tetrachloride. Each syringe scale reads 2 cubic centimeters. We will increase the temperature of the liquids uniformly. When the water bath temperature reaches 30 degrees Celsius, we can already see a difference in the expansion rate of the 3 liquids. Note the first set of syringe readings. Here's a table illustrating what happened. At 25 degrees Celsius, all the syringe readings were 2 cubic centimeters. At 30 degrees Celsius, the water syringe reading was unchanged. The oil syringe read 3 cubic centimeters, and the carbon tetrachloride syringe read 4 cubic centimeters. At 33 degrees Celsius, the water syringe read 2.4 cubic centimeters. The oil syringe read 3.6 cubic centimeters, and the carbon tetrachloride syringe read 5 cubic centimeters. Let's see an example of thermal expansion of gases. Now, let's see an example of thermal expansion of gases. This is a fancy kind of air thermometer, almost like the one Galileo invented in the 15th century. Now, let's see an example of thermal expansion of gases. This is a fancy kind of air thermometer, almost like the one Galileo invented in the 15th century. The sealed flask contains air, and as we add heat, random molecular motion of the air increases, and the air volume increases, exerting a greater pressure against the flask wall. As a result, the red liquid is forced down the tube. When the heat is removed, the red liquid will travel back up the tube due to decreased air pressure and volume. When the heat is removed, the red liquid will travel back up the tube due to decreased air pressure and volume.